explain about a project titled Detect the Flying Aeroplanes on Satellite Images Using Machine Learning. Detecting the airplanes in satellite images hold immense significance due to its wide range of applications such as surveillance, border monitoring, and the air traffic control. The conventional approach of manually analyzing the satellite imagery to identify the aircraft is both time intensive and lacking the scalability. Fortunately, the emergence of cutting edge machine learning and the computer vision technologies has introduced the novel avenues for automating this task. Our objective is to create a resilient and high performing machine learning model that can precisely and swiftly recognize the airborne aeroplane within the satellite images. This advancement promised to revolutionize the efficiency and the accuracy of the aeroplane detection, thereby bolstering the effectiveness of the various fields reliant on the airline surveillance and the analysis. This project co-objective is to develop an advanced machine learning model that can precisely identify the airplane with satellite image. This aim is achieved through a series of strategic steps. Firstly, an extensive and diverse dataset of satellite images containing the airplanes is assembled, accompanied by accurate labels indicating the airplane presence and the location. Subsequently, the crucial pre-processing activities such as resizing, normalization, and augmentation are carried out to enhance the model adaptability to novel the data, and the project involves exploring the experimenting with the range of machine learning architectures like YOLO V3, V5, V6, and V7 to identify the optimal one for the airplane detection. The selected model is then meticulously trained with a suitable optimization algorithm and the regularization technique to prevent the overfitting. This model efficacy is assessed using the precision, recall, and FN score metric. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Here we need to import the Python libraries and packages that will be required for the project such as TensorFlow, PyTorch, Flask, and image processing libraries like OpenCV. And the second one is exploring the dataset. Acquire a diverse and well-annotated dataset of the satellite images containing airplanes. This dataset will be used for training, validation, and the testing purpose. And the next step is image processing. Pre-process the image from the dataset, including resizing them to a consistent resolution, normalizing the pixel value, and handling any distortion. And the next step is loading the pre-trained model. Choose a pre-trained object detection model as a starting point, and here we use YOLO V3, V5, V6, and V7 as a popular choice due to the efficiency and the accuracy in detecting the object within the images. And the next step is data augmentation. Apply the data augmentation technique to artificially increase the dataset diversity and the robustness. Techniques like rotation, flipping, cropping, and the brightness adjustment help the model generalize better to different scenarios. And the next step is processing the data based on YOLO model. For each selected model, adopt the pre-trained architecture to the specific task of the airplane detection. And the next step is building the model. Here various YOLO models are built. The first one is YOLO V3. It is a popular object detection model known for its speed and accuracy. It divides the input image into the grid and predicts the bounding box and classify the probability for each grid cell. It typically has multiple detection scales, allowing it to capture the object of the varying sizes. In our project, we implement the V3 as one of the object detection models to identify the flying airlines and the satellite images. It provides a balance between the accuracy and speed, making it suitable for the real-time application. And the next step is YOLO V5. It is an evolution of YOLO architecture known for its lightweight design and the improved performance. It maintains the YOLO philosophy of the real-time object detection but introduced the design modification that enhance the accuracy and the efficiency. It catered to the different resource constraints, and this project it be a strong candidate due to its improved architecture, offering the better detection accuracy and potentiality faster than compared to the DOC YOLO V3. And the next one is YOLO V6. It was introduced and likely to build upon the strength of its predecessors and might incorporate the novel architectural advancement, optimizing the techniques and of the training strategy. And it could potentially offer further improvement in detecting the flying airplane on the satellite images when compared to the of the previous model. And the next one is of YOLO V7. It is very conceptualized and potentially explore even more sophisticated architecture, attention mechanism, novel training paradigm. It were designed to address specific challenges in aerial object detection and offer the advancement that enhance the accuracy and speed of identifying the fire planes and of satellite images. And the next step is user gives the input as image. Develop a user-friendly interface using the FLASH framework. Users can upload their satellite images through the interface which serve as an input to the model. And the next step is the given input is pre-processed and get trained model. Here the process the upload images to match the required input format of the chosen YOLO V5 model. This involves of resizing and the normalization. And the next one is the segmented each object and put the bounding box. Segment the each detected aeroplane using the bounding box coordinate provided by the model. This involves extracting the region of the interest from the image. And the next one is final outcome is displayed. Display the segmented airplane with the bounding box of the original image by using the FLASH as a web interface. And the next one is execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it. The data folder containing of the images, labels and the testing data within it. And the sample folder containing of the images that will be used to test the performance of the model. And the static folder containing of the folders like CSS, JavaScript, images, fonts within it. And the template folder containing of the HTML documents. It typically include a home, index, notebook, sign-in and sign-up pages within it. And the app is an PY file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user requirements. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the FLASH framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see this, the title and of some information about it. And then click on the sign up button. Here it will redirect it to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and of password that are need to be filled. And then click on the login button. Here it will redirect you to the index page containing of the choose file and the upload buttons. And click on the choose file button. Here it will redirect you to this folder containing of various images within it, and selecting one and then click on the open button. And then click on the upload button. Here it will redirect you to this page containing of the aircraft within it and with the bounding box around of the aeroplane. In this way, we can detect the airplanes without using the satellite images within it. And in conclusion, our project aimed to develop a machine learning based solution for detecting the flying airplanes on satellite images through the collection of diverse dataset, model training, and the fine tuning. We achieved a promising result in accurately identifying the aeroplanes in various environmental conditions. We chose an evaluation metric demonstrated the model's efficacy in detecting the airplane with high precision and recall. The successful implementation of the system holds a significant implication of a wide range of applications such as military surveillance, disaster response, and monitoring illegal activities in the restricted airspace. Furthermore, the project's approach can be extended to detect the other objects of interest in the satellite imagery, making it a versatile tool for the satellite-based object detection. Overall, this project highlights the immense potential of the machine learning and the satellite imagery analysis and its significant impact on the various industries and sectors.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.